So first, let's look at how laboratories create these normal reference ranges in the first place. They're not taking the 100 top healthiest, most vibrant humans on the planet to set this standard. They're taking a statistical average of everyone who walks through that lab over a specific time period. But guess who goes to the labs? It's people who are already sick, tired, or managing a chronic condition. And if you fall into the middle of that population, guess what? You get labeled as normal. So matching the average baseline to a fatigued society, that's just not health. It's delayed diagnosis. And this is the first and most dangerous example of this statistical trap. We tend to see this in how we monitor your blood sugar. So a standard fasting glucose range might look like 90 milligrams per deciliter, and your doctor will say you're not diabetic and move on. But the standard tests rarely ever look at fasting insulin and almost never check for C-peptide. When your pancreas creates insulin, it splits that prohormone into insulin and C-peptide. Now, C-peptide lasts in your bloodstream a lot longer because it's far more stable than insulin. And it tells us the absolute truth about your metabolic health. Your body could be pumping out a massive amount of insulin and C-peptide just to force your blood sugar down into that normal range. You could be profoundly insulin resistant for a decade before your standard glucose test even catches it. But what happens when your doctor tests for hemoglobin A1C? Most people view this as a simple 3-month average of blood sugar, but very few understand the actual destructive biochemistry behind that number. When you have excess glucose floating around in your system, it can spontaneously and irreversibly bind to proteins like hemoglobin inside your red blood cells. Now, this chemical reaction is called glycation. And once glucose glycates a protein, it permanently mutates it into an advanced glycation end product. And we appropriately abbreviate this as an AGE. Now, AGEs are cellular caramelization. And when these crucial proteins become glycated, they structurally warp and completely lose their function. They stiffen your blood vessels and they suffocate tissues. This is the exact biochemical destruction that causes the most devastating microvascular complications when someone has poor blood sugar control, like neuropathy or retinopathy or even the nephropathy. Another common question I always get asked is, why does the hemoglobin A1C marker only change every 3 to 4 months? Because measuring glycation of your red blood cells is the physiological lifespan of the red blood cell, which is usually about 120 days. Unfortunately, you can't cheat this test with a week of clean eating. It's an unerasable biochemical record of cellular damage.